Alright, welcome back. So we can finish up answering this question. Okay, this is another question under graphs of polynomial. Okay, so we've answered 2 questions so far, and this is the third one. Okay, so this question it was easy because the graph has already been drawn for you. Okay, as you can see, yeah, so you have the graph and you've been given the equations for the 2 graphs. Okay, so as the question says here on top, the diagram below shows part of the graph, that is of y is equal to x cubed plus 2x minus 1, and y is equal to y is equal to 10x, right? So those are the 2 equations drawn for you here. As you can see, in the y-axis we have the range from negative 20 to positive 40, and then x-axis we have negative 2 to positive 4, right? Okay, so the question that we have here, question number 1. Okay, so the first question that we have, that is question 1. As you can see, for question 1 we need to calculate. Okay, we need to use the graph above to solve the equations. So we have A, we need to solve this one, and B, we need to solve this one. Okay, so using the knowledge from the first class, the first video, the second one, we can solve this one right here. Okay, let's solve it from here. So these are the 2 equations. Okay, so this is the equation that we want to solve. Now I want to use the graph. So how do we do that? We use the original equation for the graph. Okay, as you can see, this graph here is the same one here. Okay, this is what you can see on the graph. This one curved. Okay, that's the equation. So how do we solve? Remember, we add the 2. Okay, I mean we subtract. Okay, we are subtracting the one we are solving, this one, from the one on top. All right, so if you want, you can rearrange if you are getting confused. Okay, so you have x cubed, that's plus 2x, right? You have plus 2x minus 1. Again, you can rearrange so that you can get your 6 here, so that this side you can have again x cubed, right? You can have your x cubed, that's plus 2x, yes, like this. So when you start subtracting y minus x, you are going to get y minus x, right? Okay, again, when you subtract here, that's x cubed minus x cubed, you get 0, 2x, 2x, 0. Again, you are going to have minus 1, right? So we have equal sign here. So this side we are having negative 1, right? Okay, so this is what we are getting. Okay, all right. Now if we collect the like terms, we are going to have that's 6 minus 1, and that will give us positive 5, right? Okay, so we need to plot the graph or the line y is equal to positive 5, okay, for us to find the solutions. So how do we do that? So to do that, we go at 5 and plot the line. Okay, just a moment. Okay, so just a moment there. So we have it. All right, so we have it here. I want us to use a straight line. Let me just scroll to my, okay, so we know the line that we want to draw, that is y is equal to 5. So in the y-axis you can count your 5. So remember, in the y-axis we have 2 centimeter to 1 we have 2 centimeters to 10 units, right? Okay, so from 0 at the center here to 10, we have 10 units. That means each box, small box, each of them is carrying 1 unit, right? Or let's say starting from 0, each horizontal line is 1 unit. Okay, so if you want 5, we're going to count 5 of them. So we have 1, 2, 3, 4, 5. Okay, so this is where my 5 is reaching. So I'll draw a straight line, okay, at 5 here. All right, so this is my straight line. Okay, so you need to make sure you draw a straight line. Let me just change the color so that it can be seen. All right, okay, so we have this one. This is my straight line passing at 5, right? Okay, so this one is passing at 5. It should be a straight line. Okay, so that's the one. It is passing at 5. So this equation is y is equal to, right, is equal to positive 5. Okay, so to get the solutions, we need to get the values at which it is touching our curve. Okay, so when you look at this equation, it is touching our curve only at this point. Okay, only at that point. So that point, if we, let me use red color, so it is right here. Okay, so in the x-axis we have remember, this is 2 centimeters for that's 1 unity. Okay, that means each vertical line we cross, we that's 0.1. So we have 1.1, that's 1.01, 1.02, 1.03, 1.05. okay, so we have 1.04 where we are. Okay, so this is 1.4 here. So we have 1.4. okay, so 1 centimeter, that's 2 centimeters to 1 unit. So each box is 0.1. So we have 1.1, 1.2, 1.3, 1.4, 1.5. So where we are here down, it's 1.4. So the curve that we have here, the point where our line y is equal to 5 is touching our curve is at 1.4, right? So we have 1.4, comma, so that's 1.4. So this is 1.4 again. So we have 1.4, comma, that's 5, right? Okay, so we can just write it here. Let me change the color. We maintain the color, that's black. So at the solution where this curve is touching our curve is at 1.4, right? That's 1.4, comma 5. Okay, so that's it. We can solve the second one, right? So the second one, again, want to use our graph to solve the second one, that is this one. Okay, I've already arranged that one. It is right here. Okay, so again, if you want, you can rearrange. Okay, you can rearrange this. So when you rearrange, you're going to have y is equal to x cubed. Okay, we can just anyway okay, we have x cubed here, right? So we have x cubed, that's plus 2x, right? So we have plus 2x minus 1. Again, rearranging this one, we have 10x, right? So we have 10x is equal to x cubed again. So we have x cubed there plus 2x, right? So that's x cubed plus 2x minus 1. Okay, if we subtract, we have 1 y minus 10x. We are still getting, that's y minus 10x equal to, so x cubed, that's a 0, 2x, that's a 0, negative 1, that's a 0, right? So this side we are having 0. So collecting the like terms, we have y is equal to positive 10x, right? Now how do we solve this one? So you remember the same procedure I showed you in the first graph. Okay, so you need to draw a box. So how do you do that? We need to draw a box. Okay, so let's do that from here. Okay, this is our box. Let's get this line here. So in this box we have, remember this is a linear equation, so we're going to make just 2. So we have the x values on top, we have the x values this side, and we have y values. Okay, so we assume if the x is 0 in this equation, okay, which we have obtained after solving, that is y is equal to 10x. If y there is x, we substitute with 0, our y is going to be 0 as well, right? Okay, again there is something I want you to see. Okay, just pay attention. If we substitute y with 0, x will come out as 0 as well. So we assume y is 0, x will also be 0. What is this telling you? So you remember that this equation which you have produced is the one on the graph. It has been drawn for you already, right? Okay, so this graph is the one you can see here. Okay, this is the one here, a straight line passing at the center. Okay, that's 0, 0. So this is your graph. So what they want you to do, this question, you just have to get the points at which it is touching your curve, right? So you can see in the x-axis it is touching our curve at this point. Let me change the color. Okay, so it is touching our curve right at this point here. Okay, so that point, if you check, that will give you it is giving you 0.1 comma that's 1, that's 0.1 comma 1. So at this point here, this equation or this line is touching our curve at 0.1, right? That's 0.1 comma 1 in the y-axis. Okay, what about at the other point? So the other point is here, right at the top. Okay, so this one, if you check, that's at that's 2.8. Okay, so that's 2.8 in the x-axis. So you can write it from here. So in the x-axis we have 2.8. okay, so you have 2.8 comma, what about in the y-axis? So in the y-axis, so this is your 7, not 7 but 8, because you are remaining with 2 horizontal lines on top to hit 30, right? So this is 28. Okay, so that's 28. So 2.8 comma 28, that is the point. Okay, so these are the two values that we have. So what we have to do now is to write them down here. So that's 0 comma negative 1. That's okay. For this one we can write them down. That's 0 comma 0.1 comma 1. Okay, so the values here we have the solutions. That's 0.1, okay, comma 1, and in the y-axis we are having that's 2.8 in the x-axis, right, comma 28 in the y-axis. Okay, so these are the solutions we are getting for this equation. Okay, so we can go to 2 now. I can finish this up. So for 2, we want to find the gradient, right? So we just want to find the gradient. So the gradient at the point that's 2 comma 11, right? Okay, that's 2 comma 11. So how do we find that gradient? We need to go at this point and draw a straight line. Okay, so at this point we need to check this point. So the point is 2 comma 11. So let me use different color again so that you'll be able to see. So let's use blue so that you'll be able to see this point. Okay, so the point that we are focusing on is this one, 2 comma 11. Okay, hope you're able to see it. Now we need to draw a gradient at this point. So how do we find the gradient? So first we need to draw a tangent. Remember, a tangent is nothing but a straight line touching this curve only at one point, and that point is 2 comma 11, right? So it will pass right here. Okay, now it's up to you to choose where you want your line to end. Okay, you need to choose the point that will not be a struggle for you to get the values, right? Okay, so for me, I'll extend it as long as it is touching my curve just at one point, then I can find where to end. Okay, right there, right? So that is my tangent. Now I need to get the values. So at this point, what are the values? So in the x-axis, that's 2.7, right? So that's 2.7 in the x-axis. So I have 2.7 comma in the y-axis, that's 20, right? So these are my points. That's 2.7 comma 20. Okay, again in the here at this end, this far end, in the x-axis we can check. So in the x-axis, that's 1, right? That's 1 in the x-axis. What about in the y-axis? So in the y-axis, remember, in the y-axis, that's 2 centimeters for 10 units. Okay, so where we are, we have to count. So we have 1, 2, 3, 4, right? So that's 1 comma, that's 1 in the x-axis. In the y-axis, that's negative 4, right? Because these are negative values, so that's negative 4. Okay, because this is negative 10 there. So we have negative 1 comma 4. We can write them down. That's negative 1 comma 4. So at this point we have the values negative 1, okay, comma 4, and that's positive 1 comma negative 4. Okay, so that's positive 1 in the x-axis comma negative 4, that is in the y-axis. That's the first point. Now the second one you can check. So the second one was 2.7 comma 20. So that's 2.7, okay, comma 20. That's 2.7 comma 20. Now using the equation for the gradient, we have, remember the formula, that's y2 minus y1, right? You divide this by x2 minus x1, right? So what is your x2 here? Okay, so your x2 is 20, right, minus your x1, that's 1. That's our y and not x. So we have our y2, that's 20, then our y1, that's negative 4. So we have negative 4 there. And then at the bottom we have our 2.7, right? We have our 2.7 minus 1, right? So again, on top we are getting 24. Okay, you add, you have 24. Then here down you have 1.7. All right. Okay, so you can use your calculator and find the final value there, and that will be your gradient, right? So you can just use a calculator and finish up there, but this is what we are getting as our gradient. So this is showing us how slanting the line is at this point, that is 2, 11. So you can answer the last question there. We need to estimate the area. Okay, so that will be our last question, and that's B. Okay, so we can write it here. That's 2B, right? So that's our 2B. Okay, the previous one, that's our 2A. Okay, so how do we find the area? So we need to locate first. So the area is bounded by the equation y is equal to 10x. Okay, we know that equation, that is a straight line. Okay, again we have y is equal to 0. Okay, so the y is equal to 0, we've seen it. Okay, again we have the other one, that is x is equal to 2. Okay, so we need to mark this area. Okay, so we can do that in x is equal to 2 is one of our area. Okay, so that's starting from this line, okay, up to there. Again we have y is equal to 0, so we extend this down up to we hit the x-axis. Again we make a 10 here, okay, until we have y is equal to 0. Okay, this is y is equal to 0, right? Okay, now it should extend until it hits the line or the curve y is equal to 10x. Okay, so this line is y is equal to 0. It's one of the boundaries, right? Okay, so we have it there. We have x is equal to 2, so just a mistake here. Okay, we were at 3 in the x-axis and not at 2, so that's here. Okay, so 2 is right here and not where we wanted to plot. Okay, and then in the x-axis we extend this up to this far. Okay, and then at this point we extend this up to this far. Okay, so you are able to identify the shape, right? Okay, you can see the shape that we are getting. This is a triangle. Okay, so we need to calculate the area for this region. Okay, so this is a triangle and that should be easy. You need to know your base. Okay, so the base, that is the line, the distance, so that is the distance from 0, okay, from this point here to up to 2. And we know that in the x-axis we know that it's 2 centimeters to 1 unit, so we have 2 here, right? So 2 will be our base. Okay, what about our height? So our height is right here from top there 20, or you can say from 0 to 20, so this is 20 again, right? So we can now calculate the area. We know that that's 2 by 20. Okay, so applying the formula for the area. Okay, let me change the color again. Okay, so this is the last question. So the area, we are using the formula for the area of a triangle, so that's half, right? Half multiplied by that's BH, right? Multiplied by your base, again by your height. Alright, so we just have to substitute. Okay, I'll use the other method as well, the one for counting, so that you can get the concept here. So we have half, okay, multiplied by, what is our base? Our base was 2, multiplied by, what was our height? Our height was 20, right? Okay, you apply cancellation rule and you are going to get your area to be 20, not 20 centimeters, but 20 units. Okay, so we use units. All right, so this is the area. Okay, now if you apply that method of counting, again you need to analyze this. Remember, one box, okay, this box that you have is in the x-axis is one unit per 2 centimeters. You have 1 unit, right? Now in the y-axis, per 2 centimeters you have 10 units, right? So the area for just one full box, okay, one complete box, is 10 units. That's the area. So you need to estimate from this one, okay? So from this one, how many box can you have? So you check that from here, this box, okay, within the triangle, this box is a complete one, okay? So that means you have 10, right? Again, this one here on top, you have half of a box, right? Okay. Again, this one down here, you have half of a box, right? Okay, so when you add this half, okay, and this half on top, you have one complete box, and this one complete box. So you have 10 plus 10, okay? So even this one, you find that it is giving you the same area, right? So you have, that's 10 plus 10 when you use the method of counting, and this will give you 20 units as well. So whichever method you use, you will still get the same answer, okay? Both you are getting 20 units as the estimate of your area, okay? So thank you so much for watching. Join us in the next class, okay? If there is any question, make sure you post on WhatsApp. I'll be able to attend to you, okay?